The year is 2025. At precisely 9:18 a.m. on Mars local time, NASA's Perseverance rover recorded an anomaly in the sky above the red planet. The space agency subsequently disseminated the imagery via their official multimedia portal. The visual evidence prominently features an object, meticulously outlined in green by NASA itself. This was not a casual snapshot. It was not a nebulous capture from a fringe theorist device. This was an official NASA photograph, acquired by the SkyCam, a camera oriented skyward atop the rover's deck, documenting an unusual celestial presence. A mere 24 hours later, on the 3rd of October, 7 orbital vehicles representing 4 distinct international space organizations were perfectly positioned to capture the most intimate and detailed views ever obtained of the interstellar phenomenon identified as 3 Atlas. Following this, a profound silence descended. 4 full days elapsed with no new information emerging. 4 days during which NASA, China, and the United Arab Emirates provided absolutely no updates. Then, on this day, the 7th of October, the European Space Agency finally broke the extended quiet. They unveiled images, appearing as indistinct white smudges, indicative of a comet exhibiting a coma, entirely ordinary and as anticipated. However, this is precisely what renders their disclosure profoundly unsettling. If ESA's imagery depicts something so unremarkable as to warrant immediate publication, why do NASA, China, and the UAE continue to withhold their findings? Why has NASA not yet shared the images from Perseverance taken on October 3rd? Why has China, an entity that annually releases thousands of Martian images and consistently showcases its technological prowess, not divulged anything from its Tianwen-1 mission? ESA presented us with a blurry spec stating, "We require weeks, perhaps months, for analysis." What did the other entities observe that they are entirely unable to reveal? Because as we understand it, the mathematical probability of this object's trajectory should simply not exist. Its likelihood is 1 in a million. It is emitting metallic elements in a manner that defies fundamental physical laws. Its age predates our entire solar system, and within 21 days, it is projected to traverse behind the Sun, rendering it completely invisible to every terrestrial telescope at the precise moment when solar radiation should either disintegrate it or, if certain hypotheses hold true, provide the ultimate cover for its subsequent actions. NASA revealed something on October 2nd. 7 orbital craft observed something on October 3rd. ESA presented faint smudges on October 7th, and the agencies possessing the most sophisticated optics, the instruments with the highest resolution capabilities, the most granular data, remain reticent. The pertinent inquiry is not the nature of 3E Atlas. The crucial question is, what did NASA and China discern that ESA either failed to detect or deliberately omitted from their report? If you share my fascination with this enigma, kindly engage with the like button and subscribe for ongoing updates. In the comments section, please indicate your listening location, the current time there, and whether you believe ESA's release heightens or diminishes the suspicion surrounding this event. To assist in expanding our community, please share this content on X, Facebook, Reddit, or your preferred messaging platform. Your continued support is greatly appreciated. Bonus chapter, urgent news update. Before we proceed, a brief notification. This segment has been appended following the conclusion of the original recording. On October 7th, 2025, mere hours after we completed the primary narrative, the European Space Agency disseminated the inaugural official imagery and data pertaining to the October 3rd Martian flyby. This is developing news that fundamentally alters the trajectory of our understanding. Consequently, we have incorporated this bonus chapter to address the revelations from ESA and, equally importantly, what they continue to keep concealed. Let us delve into what is presently known. The extended silence has finally been breached. The period of anticipation has concluded, at least partially. On October 7, 2025, the European Space Agency accomplished what NASA, China and the UAE have thus far refrained from doing. They released photographic evidence. They published data. They shattered the pervasive silence that has enveloped this narrative since October 3rd. However, this action is simultaneously illuminating and profoundly frustrating. The information they have shared generates as many unanswered questions as it resolves. Furthermore, what they have yet to release may prove to be of even greater significance than what has been disclosed. Let us begin with the evidence actually presented by ESA, the ExoMars Trace Gas Orbiter, utilizing its CASIS camera, the Color and Stereo Surface Imaging System, captured a sequence of images between October 1st and 7th. These visuals have been synthesized into an animation, a GIF depicting the comet's movement against the backdrop of static stars. And there it is, 3 Atlas, a subtly indistinct white dot, positioned near the frame's center, traversing downwards through the field of view. This constitutes the official description provided by ESA, a subtly indistinct white dot. Now, before any sense of disappointment takes root, let us comprehend precisely what we are observing and the immense challenges involved in this particular observation. CASIS was engineered for the specific purpose of photographing Mars. It is optimized for imaging the planet's bright surface from distances ranging from several hundred to a few thousand kilometers. Its design is dedicated to capturing geological formations, surface textures, and variations in the color of Martian rock and sand. 3 Atlas, however, was located 30 million kilometers away. 30 million kilometers. That is 100 times the typical observational range for CASIS. Furthermore, unlike the intensely luminous Martian surface, the comet is exceedingly faint. Exceptionally faint. Nick Thomas, the principal investigator for the CASIS camera, stated that 3 Atlas registers approximately 10,000 to 100,000 times dimmer than the instrument's standard targets. The mere act of capturing it necessitated exposures lasting 5 seconds, an exceptionally prolonged duration for this particular camera. The imagery does not resolve the nucleus itself. At a distance of 30 million kilometers, discerning the nucleus, which might measure only a few kilometers in diameter, would be akin to attempting to spot a mobile phone situated on the Moon from Earth. An impossibility with this instrument. What is visible is the coma, the diffuse envelope of gas and dust encircling the nucleus. ESA reports that this coma spans several thousand kilometers in diameter, a substantial size. This observation confirms that 3 Atlas is actively outgassing, releasing volatile substances as solar radiation heats its surface. This behavior is entirely consistent with that of a typical comet. As a comet approaches the Sun, it develops a coma. The closer it gets, the larger and brighter the coma becomes. The captured images do not yet show a tail. Comet tails form when solar wind propels gas and dust away from the nucleus, creating those spectacular streamers that can extend millions of kilometers into space. However, tails are considerably less luminous than comas. At the time these observations were made, if a tail existed, it was too faint for CASIS to detect. ESA notes the possibility that a tail might become apparent in subsequent observations as the comet continues to warm and increase its activity. To date, there is nothing anomalous or extraordinary. It appears to be a comet with a coma behaving precisely as expected. One might even describe the situation as anticlimactic, given the preceding speculation, theories, and period of waiting. However, this is where the situation becomes intriguing. This is where the carefully chosen phrasing in ESA's announcement reveals as much by omission as by inclusion. Mars Express, ESA's other Mars orbiter, also attempted to observe 3 Atlas, but the comet has not yet become discernible in those images. The exposure time was restricted to half a second, the maximum permissible for the Mars Express camera, in contrast to the 5-second exposures of ExoMars. This shorter duration means the comet was simply too faint to register with clarity. Nevertheless, ESA scientists are currently engaged in the process of combining multiple Mars Express images, stacking them together, aggregating the signal from several frames to enhance the visibility of the faint comet against the background static. This is a standard astronomical technique. When an object is too dim to be observed in a single exposure, numerous images are acquired and superimposed. The signal gradually amplifies, while the noise averages out, allowing features to emerge. The question arises, why are they undertaking this effort? If the ExoMars images already reveal the comet sufficiently to confirm its presence and the existence of a coma, why expend the considerable effort of stacking Mars Express images to extract further data? The reason is that they are actively searching for something specific, something they hope additional observations will either elucidate or definitively rule out. Then there is the matter of spectroscopy. ESA attempted to employ 3 distinct spectrometers to analyze the light emanating from 3E Atlas. Mars Express is equipped with the Omega and SPECAM instruments, while the ExoMars TGO carries the Nomad instrument. All 3 devices were directed towards the comet during the flyby period. Spectrometers do more than simply capture images. They dissect light into its constituent wavelengths, thereby revealing the chemical composition of whatever is emitting or reflecting that light. However, ESA is not being forthright about a crucial detail. They have not clearly stated whether they successfully obtained spectroscopic data. The announcement declares that, at this juncture, it remains uncertain whether the coma and tail were sufficiently luminous for spectral characterization. Uncertain. Not a definitive yes, nor a definitive no. Uncertain. This ambiguity carries immense weight, because if they acquired usable spectra, they would possess knowledge of its chemical makeup. They would know if the signature of nickel is present. They would know if the dominance of carbon dioxide is confirmed. They would be aware of any unusual elements or compounds that deviate from natural expectations, and if they possess this knowledge, they are evidently choosing to withhold it for the time being, opting to state that data acquisition is uncertain, rather than revealing the actual findings. The announcement concludes with a projected timeline. Scientists will continue their analysis of the collected data over the ensuing weeks and months. Weeks and months, not days, not a rapid preliminary report, but an extended period of analysis, a meticulous examination, taking their ample time to ascertain the composition and behavior of 3E Atlas. So, what precisely has ESA provided us with? They have confirmed the existence of the comet. They have verified the presence of a coma. They have presented images that, at first inspection, appear entirely consistent with standard cometary activity. They have broken their silence just enough to declare, yes, observations were made, yes, it is present, yes, it resembles a comet. Yet they have been exceptionally careful to avoid making any definitive statements regarding its composition, its unusual characteristics, or any perceived anomalies. Those answers, should they possess them, are being reserved for further analytical processes. Now let us consider the potential motivations behind ESA's decision to release this information. While NASA and China maintain their silence, several possibilities exist, and these are not mutually exclusive. Firstly, ESA might genuinely possess the least compelling data. The ExoMars and Mars Express missions are highly capable spacecraft, but their cameras and spectrometers are not as powerful as some of NASA's advanced instruments. NASA's Mars Reconnaissance Orbiter, for instance, is equipped with HiRISE, which should have captured images of significantly higher resolution. If these superior images reveal something unexpected, something that necessitates extensive analysis before public dissemination, NASA might be delaying its release, while ESA, possessing less detailed observational capabilities, feels comfortable proceeding with publication. Secondly, ESA operates independently of any potential United States government shutdowns. They are unaffected by furloughs, budgetary disputes, or political complexities. If they completed their preliminary analysis and deemed their data ready for release, they could simply publish it, free from bureaucratic delays or the need for coordination with agencies that may currently be understaffed. Thirdly, and this is purely speculative, ESA might be applying subtle pressure on NASA and China by releasing their own observations. Even if preliminary, these releases establish a benchmark. They're effectively stating, here is what we observed, here is what we are prepared to share. Now what about your findings? This action cultivates public anticipation and renders the continued silence from other agencies even more conspicuous. The question that everyone should be posing at this moment is this. If ESA's images depict a conventionally appearing comet with a commonplace coma and no apparent anomalies, why do NASA and China persist in their silence? Why has NASA not yet released the images from Perseverance taken on October 3rd? Why has China not disclosed any information from Tianwen-1? Why is data from the UAE's Hope orbiter still withheld? ESA has demonstrated that indeed, observations were undertaken and indeed they can be published. So, what is impeding the other agencies? Colin Wilson, ESA's project scientist for Mars Express and ExoMars, made a notable statement within the announcement. He remarked, "It is always exceptionally exciting to witness the orbiters responding to unexpected situations." Unexpected. This is a curious choice of word. 3 Atlas was predicted months in advance. Its passage was scheduled. Spacecraft were deliberately positioned to observe it. What aspect of this event was unexpected? The trajectory was not unexpected. The arrival date was not unexpected. The fundamental occurrence of an interstellar comet transiting Mars was not unexpected. Therefore, to what does unexpected refer? Was it the comet's behaviour, its appearance, or something within the data that deviated from predictions? We are, in essence, interpreting subtle clues here, analysing word choices, and searching for indications in both what is stated and what is deliberately omitted, as that is all we currently possess. They have presented us with indistinct white dots, employed careful language, and promised further analysis in the coming weeks and months. The silence has been broken, but only in the most restrained manner possible, just enough to confirm that observations took place, just enough to suggest a typical cometary appearance, merely enough to make the ongoing silence from NASA, China and the UAE even more pronounced than before. Whatever was observed, whatever data those other spacecraft collected, it is still being kept from public view, and ESA's release, rather than providing definitive answers, may have inadvertently amplified the urgency of the most critical question. If what ESA has shown us is sufficiently unremarkable to warrant immediate publication, then what did the other agencies witness that necessitates weeks or months of analysis before any public disclosure can be made? Chapter 1. The 9 Spacecraft Holding the Truth. Let us commence with what we know with absolute certainty. On October 3rd, 2025, at 400 Coordinated Universal Time, the interstellar object designated 3 Atlas achieved its closest proximity to Mars. The distance recorded was 29 million kilometers. In astronomical terms, this represents an exceptionally close approach. It was close enough to present us with an unprecedented opportunity, an opportunity that arises perhaps only once in a human lifetime. 7 orbital vehicles were strategically positioned around Mars at that precise moment. 7 distinct sets of instruments, 7 varied vantage points, representing 4 separate space agencies, all directed towards the same target, all simultaneously collecting data. The first of these is NASA's Mars Reconnaissance Orbiter, launched in 2005 and still operational after 2 decades in Martian orbit. Its paramount instrument is the HiRISE camera, the high-resolution imaging science experiment. This camera possesses the capability to resolve objects down to 30 centimeters from Martian orbit. However, for 3 Atlas, situated 30 million kilometers away, the resolution would equate to approximately 30 kilometers per pixel. This might not initially seem impressive until one considers a critical factor. This represents the highest resolution imaging of an interstellar object ever achieved. throughout the entire history of human astronomical observation. Reflect on that for a moment. Every other interstellar visitor we have detected, Oumuamua in 2017, Borisov in 2019, we only managed to capture them as they were departing, appearing as distant points of light already receding from us. But 3 Atlas, we have been tracking its trajectory since July, and on October 3rd, we had the perfect observational window. The second spacecraft is the European Space Agency's Mars Express. Launched in 2003, it carries the high-resolution stereo camera, primarily designed for mapping the Martian surface in 3 dimensions. However, cameras are not selective about their targets. Mars Express possesses the capability to generate 3-dimensional structural maps of the comet's coma, the diffuse cloud of gas and dust surrounding its nucleus. This could reveal its shape, the distribution of its density, and any asymmetries in its outgassing patterns. The third is another European spacecraft, the ExoMars Trace Gas Orbiter, a collaborative endeavour with Russia's Roscosmos. This mission carries NOMAD, the nadir and occultation for Mars discovery instrument, and CASSIS, the colour and stereo surface imaging system. NOMAD is a spectrometer engineered to detect trace gases in Mars' atmosphere with remarkable sensitivity. Yet, when a spectrometer is aimed at a comet, it is designed to analyse something far more compelling than Martian air. It is capable of determining the chemical composition of material that originated in another star system billions of years ago under conditions that are almost beyond our comprehension. Then there is NASA's Mars Odyssey Orbiter, launched in 2001, making it one of the longest-serving operational spacecraft at Mars. Its THEMIS instrument, the Thermal Emission Imaging System, captures infrared data. It measures thermal signatures, and if 3 Atlas were experiencing any unusual thermal activity, any unexpected energy output, or any hotspots that should not logically be present, THEMIS would be instrumental in detecting it. The 5th spacecraft is one we have already mentioned, Perseverance. This rover is currently situated on the Martian surface within Jezero crater. Its SkyCam, mounted on the rover's upper deck, already recorded an anomaly on October 2nd. But what about October 3rd? What was captured at the moment of closest approach? Perseverance is equipped with multiple cameras. It also possesses spectroscopy equipment. It was the sole ground-based observer with a direct line of sight. The 6th spacecraft is China's Tianwen-1 orbiter, and this is where the situation takes a markedly different turn. Tianwen-1 has been in orbit around Mars since February of 2021. During that period, the China National Space Administration has disseminated more than 14,000 images from the mission. 14,000. They publish their findings regularly. They publicize their achievements. Space exploration is a matter of national pride, and China leverages every opportunity to showcase its technological capabilities to the global community. However, concerning 3i Atlas, there has been a complete lack of communication. Not a single image, not a single data release, not even an acknowledgement of their attempted observations. The 7th is the United Arab Emirates Hope Orbiter, also known as the Emirates Mars mission. Hope carries the Emirates Mars infrared spectrometer, designed to study the Martian atmosphere, but it is perfectly capable of gathering spectroscopic data on a passing comet. The UAE has demonstrated remarkable transparency with its mission data, sharing images, engaging in international collaboration, and making its findings publicly accessible. Yet, for 3 Atlas, a similar silence prevails. Now, it is essential to discuss what is yet to come, as this narrative is far from concluded. It has scarcely begun. In late November, between the 2nd and the 25th, the European Space Agency's JUICE spacecraft, the Jupiter Icy Moons Explorer, currently en route to the outer solar system, will direct its instruments towards 3 Atlas. JUICE will observe the comet subsequent to its closest approach to the Sun after perihelion, when it is expected to be at its most active, when the solar heat has triggered maximum outgassing, and when any unusual phenomena are most likely to occur. However, there is a complication. JUICE is presently positioned relative to the Sun in such a way that it presents a communication challenge. The data it collects in November will not be transmitted back to Earth until February of 2026. This signifies a 4-month waiting period, 4 months of uncertainty regarding what JUICE observed. Furthermore, there exists the possibility, still under active consideration, of redirecting NASA's Juno spacecraft for a close encounter in March of 2026. Juno is presently in orbit around Jupiter, engaged in the study of the gas giant's atmosphere, magnetic field, and internal structure. However, Juno possesses remaining fuel reserves, and its instruments are fully functional. 3 Atlas will pass within approximately 54 million kilometers of Jupiter on March 16, 2026. A trajectory adjustment initiated in September of this year could position Juno for a flyby at roughly 25 million kilometers. This distance is closer than the Martian encounter. It is close enough for detailed imaging and spectroscopy that could finally provide answers to some of the questions that are causing considerable consternation among astronomers. However, NASA has not yet sanctioned this maneuver, and with the ongoing government shutdown, with 15,000 NASA employees on furlough, and with the agency effectively paralysed, this crucial decision is caught in a bureaucratic stalemate. Consequently, we have 7 spacecraft that observed the October 3rd flyby. We have 1 spacecraft that captured preliminary images on October 2nd. We have future observations planned for November and potentially for March of the following year. And out of all these efforts, out of all these instruments, all these agencies, and all this collected data, what has been released to the public? 1 image from Perseverance's SkyCam taken on October 2nd, published on NASA's raw image page, depicting something within the Martian sky circled in green, and thereafter, nothing. Chapter 2. Perseverance. SkyCam images October 2nd. Let's delve into what NASA has officially released, as this is not conjecture or hearsay. These are authenticated images sourced directly from NASA's Mars 2020 raw image archive. Their existence is confirmed, complete with timestamps and labels, and accessible to anyone with an internet connection. The image in question was acquired on Sol 1642, which represents the Martian day count since Perseverance touched down in Jezero crater. Sol 1642 corresponds to October 2nd, 2025 by Earth's calendar. The precise timestamp recorded is 9/1848, Mars local mean solar time, indicating a morning period on the red planet. The Sun had been above the horizon for approximately 3 hours. The instrument responsible for capturing this image is officially designated as the Perseverance SkyCam. It is affixed to the rover's top deck, the flat surface where the majority of the scientific instruments are situated. Unlike the navigation or Mars-mounted cameras that focus forward and survey the horizon, this SkyCam is oriented directly upward. Its intended purpose is to monitor the Martian atmosphere, observing phenomena such as dust devils, cloud formations, and the gradual changes in atmospheric density as dust storms emerge and subside. However, on October 2nd, it documented something entirely different. The initial image reveals what appears to be a circular formation, slightly warped due to the camera's wide-angle lens. A distinct object is clearly visible in the upper section of the frame. NASA's own image processing division has encircled it in green. Let that detail resonate for a moment. This is not an amateur astronomer pointing out a pixelated anomaly. This is NASA's official multimedia page, featuring an annotation added by NASA personnel, drawing attention to an object in the Martian sky. The second image offers a broader perspective, showcasing more of the SkyCam's complete field of view. Within this frame, one can observe the camera's own circular housing and the characteristic fisheye distortion at the periphery. And there, in the upper right quadrant, the same object is discernible. It is faint, yet present. It is not a malfunctioning pixel, nor a spurious cosmic ray impact, nor a processing artifact. Its displacement between frames signifies genuine movement relative to the camera. This is technically significant for a crucial reason. The Skycam is not engineered as a high-resolution instrument. Its design prioritizes wide-field surveillance over detailed imaging of distant subjects. Its primary function is atmospheric observation, tracking phenomena within the Martian sky at relatively close proximity. The very fact that it captured this object at all is telling. It indicates that the object possessed sufficient luminosity to be registered by a camera not intended for astronomical observation, bright enough to stand out against the Martian daytime sky. Although this sky is considerably dimmer than Earth's due to Mars' tenuous atmosphere, it is by no means approaching the darkness of night. This observation was not made during Martian evening or pre-dawn twilight. It was mid-morning. Yet, there it is. The distance to the object at the time of this image acquisition was approximately 30 million kilometers. This was the separation between the object and Mars on October 2nd. For context, this distance is about 80 times the span between Earth and the Moon, a vast expanse of empty space. And Perseverance's upward-facing camera, with no specific expectation of capturing anything beyond Martian weather patterns, nonetheless detected it. Now, the timeline takes on critical importance. October 2nd was not the point of closest approach. That occurred 24 hours later, on October 3rd. The object was still in transit, still approaching, and consequently growing brighter as it neared Mars. This raises the question, what did Perseverance capture on October 3rd? We do not know, as NASA has not released those images. The raw image archive for Perseverance is typically updated within a few days of image capture, sometimes even within hours. The rover continuously acquires thousands of photographs. These are relayed to Earth via the Mars orbiters, which act as communication satellites. The data is received at the Deep Space Network stations located in California, Spain, and Australia. Subsequently, it is routed to the Jet Propulsion Laboratory in Pasadena and then uploaded to the public archive. This process is largely automated and does not involve human intervention to decide which images are published. The images simply pass through the established pipeline and appear on the website. This system has been operational for years, with images from Curiosity appearing punctually, and Perseverance's images following suit. However, this consistent pattern appears to have been broken for the images from October 3rd, the day of closest approach, which would have provided the clearest view of the object at its nearest point to Mars, when it was at its brightest and most observable by any human-made camera. These particular images are conspicuously absent. One might suggest that Perseverance was occupied with its primary mission objectives, such as collecting rock samples, studying Martian geology, or searching for evidence of ancient microbial life. It operates on a schedule with defined priorities. It's conceivable that the science team did not task the rover with observing the object on October 3rd, perhaps being focused on drilling a core sample or navigating to a new location. However, we know this is not the case, as the official mission plan indicates that multiple spacecraft were coordinating observations of the object during its Martian flyby. This event was recognized as significant, and NASA publicly stated its intention to observe it. Furthermore, Perseverance is equipped with multiple cameras capable of being directed skyward at any point during the Martian day on Sol 1643, which corresponds to October 3rd. The rover does not need to cease its operational tasks to capture an image of the sky. It can perform both functions concurrently. The Skycam is perpetually active, consistently pointing upward, ready to record any celestial passage. So where are these images? There is another detail that warrants examination. The image from October 2nd was not prominently featured or highlighted by NASA. It was not accompanied by a press release, nor was it included in any mission updates or news articles. It simply materialized in the raw image archive, much like thousands of other images, with basic metadata and no accompanying commentary. The green circle annotation was a subsequent addition, presumably made by someone browsing the archives who noticed the object and brought it to attention. NASA's multimedia team frequently adds annotations to noteworthy images, indicating geological features or unusual atmospheric occurrences. This is standard procedure, but the timing of this annotation is particularly interesting. The annotation appeared, the image began circulating on social media, and then a conspicuous silence ensued. One might also inquire about the images from the orbital missions, as Perseverance was not the sole camera pointed toward the object on that day. The Mars Reconnaissance Orbiter was overhead, Mars Express was in position, and Odyssey was operational. These orbiters possess significantly more powerful cameras than a rover's Skycam, and thus should have captured far superior images, and perhaps they did. We simply have not seen them. A discernible pattern is emerging, and it is not subtle. On October 2nd, one day prior to the closest approach, an image surfaces depicting the object in the Martian sky. It is published automatically as part of the standard data dissemination process. Someone identifies it, annotates it, and it begins to garner interest. Then, on October 3rd, the day of closest approach, when 7 spacecraft were simultaneously conducting observations, and we should have been privy to the most exceptional images ever obtained of an interstellar object, nothing is released. This lack of release extends to Perseverance, the Mars Reconnaissance Orbiter, Mars Express, Odyssey, and all other participating missions. The automated data flow appears to have been interrupted. Or, perhaps more accurately, it is being deliberately held back because data does not simply vanish. It exists. It resides on hard drives at the Jet Propulsion Laboratory, on servers at the European Space Operations Centre, and within archives at the China National Space Administration. It is tangible. We are, however, being denied access to it. Now one must ask why this is the case. Why would NASA release an image on October 2nd, permit its annotation and subsequent sharing, and then withhold all subsequent data? There are essentially 2 plausible explanations. The first is mundane: technical issues, data corruption, communication failures, or a government shutdown impacting routine operations. It's possible the images are currently held in a queue, awaiting processing by furloughed employees who are not presently at their workstations. This scenario suggests a perfectly reasonable explanation unrelated to the actual content of the images. The second possibility is less ordinary. The images might reveal something unexpected, something that necessitates careful analysis before public disclosure, something that potentially requires discussion and coordination among multiple space agencies before any official statement can be made. The image from October 2nd presents an object in the sky, a mere point of light, nothing more. However, points of light do not typically warrant coordination between NASA, ESA, CNSA, and the UAE. Points of light are generally published automatically, analysed by the scientific community, and discussed openly in academic papers and press releases. Therefore, what did the camera capture on October 3rd that a mere point of light on October 2nd failed to prepare anyone for? What transformation occurred within those 24 hours as the object drew nearer, as its resolution improved and its details became clearer? We do not know, but 7 spacecraft do, and 4 space agencies do. And somewhere within secure facilities across 3 continents, individuals are examining images that we are not permitted to see. Chapter 3: 4 Days of Silence. What transpired afterward? Today is October 7th, 2025. It has been precisely 4 days since the closest approach. 96 hours have elapsed since 7 spacecraft observed the object at its most detailed resolution ever achieved for an interstellar entity. And throughout these 96 hours, the silence from the world's space agencies has been, to put it mildly, profound. Let us establish what constitutes normal procedure. To appreciate the significance of this silence, one must understand the extent to which it deviates from standard operating protocols. When Mars missions acquire compelling data, it is disseminated promptly. NASA's Mars Reconnaissance Orbiter routinely publishes high-resolution images of the Martian surface, often within days of their acquisition. These are not mere routine mapping photographs. They are detailed observations of dust devils, avalanches on crater walls, newly formed impact craters, and seasonal shifts in the polar ice caps. The images are made available on NASA's website, complete with explanatory captions. They are featured in press releases and shared on social media by NASA's Public Affairs Office. The European Space Agency adopts a similar approach with its Mars Express mission. When the spacecraft captures something noteworthy, such as a dust storm, a mineral deposit, or an unusual geological formation, ESA disseminates it. They publish articles, provide context, and invite planetary scientists to offer their commentary. Information flows outward to the public as a matter of routine. However, this is where the situation becomes particularly intriguing. China's approach to space endeavours is, in many respects, even more assertive in its public relations. The China National Space Administration views space exploration as a projection of national prestige. Every successful landing, every orbital insertion, and every scientific discovery is an opportunity to showcase technological prowess to the global community. When Tianwen-1 successfully entered Mars orbit in February of 2021, CNSA released images within mere hours. When the Zhurong rover touched down on the surface in May of that same year, the images were released immediately, presented in high resolution, color-corrected, and professionally processed. Since Tianwen-1's arrival at Mars, CNSA has published more than 14,000 images from the mission. 14,000? That equates to an average of nearly 12 images per day for 4 consecutive years. These images depict the Martian surface, the rover's tracks, rocks, dunes, and even the Chinese flag emblazoned on the lander. They showcase a comprehensive visual record, as the act of revealing everything demonstrates China's capacity to compete on equal footing with NASA and ESA. Consequently, when the object in question, the most significant interstellar body to traverse our solar system in recorded history, approached within 30 million kilometers of Mars, what did CNSA release? Nothing. Not a single image, not one data set, not a solitary press statement, not even an acknowledgement that Tianwen-1 had undertaken observational efforts. This behavior is entirely atypical for CNSA, deviating from every pattern they have established over 4 years of Mars operations. Had the mission captured images of the object, and had those images revealed precisely what was expected, a typical comet exhibiting a standard coma and tail, CNSA would have published them instantly. They would have celebrated the acquisition of an interstellar visitor and leveraged it as evidence of their advanced imaging capabilities. In all likelihood, they would have preempted NASA, releasing their data first simply to underscore China's earlier achievement. But they did not. They maintained absolute silence. One might argue that the United States government shutdown provides a plausible explanation for NASA's silence. To a certain extent, this argument holds merit. As of October 1st, 2025, more than 15,000 NASA employees were furloughed, representing 83% of the agency's workforce. The Jet Propulsion Laboratory, which manages the majority of NASA's Mars missions, is currently operating with a minimal staff. Data processing pipelines that typically function seamlessly are now navigating through bureaucratic inertia. However, this explanation encounters a significant obstacle. The government shutdown is exclusively an American phenomenon. It does not affect the European Space Agency, nor the China National Space Administration, nor the United Arab Emirates Space Agency. These are independent entities located on different continents, possessing distinct funding structures and operating under differing political circumstances. ESA's budget is derived from the member states of the European Union. CNSA answers to the Chinese Communist Party. The UAE's space program is financed by the Emirati government. None of these organizations are subject to American fiscal disputes, nor do they have furloughed employees. Consequently, They have no operational justification for delaying the release of data pertaining to the object. Yet they remain silent. CNSA is silent. The UAE is silent. This is where we must examine the nature of coordination within the space exploration community, as these agencies do not typically collaborate on all matters. In fact, their coordination is rarely extensive, often limited to basic safety protocols and frequency allocation to prevent communication interference. NASA and CNSA in particular maintain a relationship that can best be characterized as competitive rather than hostile. Legal constraints exist regarding cooperation between American and Chinese space programs. The Wolf Amendment, enacted by the US Congress in 2011, prohibits NASA from utilizing federal funds to engage in space-related cooperation with China without explicit congressional authorization. This stipulation means that NASA and CNSA do not freely exchange data, nor do they collaborate on joint missions or coordinate scientific announcements. Instead, they compete, observing each other's progress and striving to surpass one another. When China successfully lands a rover on the far side of the Moon, NASA responds by accelerating its Artemis program. When NASA lands Perseverance on Mars, China counters by landing Zhurong. This is the prevailing dynamic. Therefore, when both NASA and CNSA simultaneously fall silent regarding the same event, it signifies more than normal competition. It indicates coordination, something entirely different. The same logic applies to ESA. While ESA and NASA do collaborate on numerous projects, they remain distinct entities with independent priorities. When ESA possesses significant data, they disseminate it autonomously. They do not solicit NASA's approval, nor do they consult Washington before releasing images from Mars Express. They operate independently. However, this instance is different. This time, ESA is silent, while NASA is silent, while CNSA is silent, and while the UAE is silent. 4 agencies, 4 continents, 4 distinct political systems, all maintaining silence regarding the same event. There is a relevant idiom here. When everyone speaks, no one listens. When everyone remains silent, the silence itself becomes audible. Consider the effort required to achieve this outcome. Envision the discussions that must have transpired. NASA officials reaching out to their ESA counterparts, ESA contacting CNSA, and someone coordinating with the UAE. An agreement has been reached that nothing will be released until what precisely? Until everyone has had sufficient time for analysis, until everyone concurs on the interpretation of the data, until everyone has collectively decided how to present it to the public. These are not discussions that occur for routine observations. These are not conversations that take place for a typical comet traversing the solar system. These are conversations that are initiated when something unexpected emerges in the data, and no one wishes to be the first to articulate it. There is a discernible pattern in how scientific anomalies are managed. When an unusual finding appears in data, the initial impulse is not immediate publication. The primary instinct is to verify, to confirm with absolute certainty that the observation is genuine and not the result of an instrument malfunction, a processing error, or a cosmic ray event that coincidentally appeared unusual. Consequently, diagnostic tests are performed, data is reprocessed, comparisons are made against calibration standards, colleagues are consulted, and every conceivable mundane explanation is meticulously and systematically ruled out before the possibility of a genuinely anomalous phenomenon is even considered. This constitutes sound scientific practice and is the correct methodology. The challenge, however, is that it typically does not necessitate the coordinated silence of 4 independent space agencies while this process is underway. This suggests a potential scenario where they all observe the same anomaly, requiring mutual verification and absolute certainty before any announcement is made, because once a statement is issued, it cannot be retracted. And so, here we are, on October 7th, 4 days following the closest approach. The data exists somewhere on JPL's servers, within ESA's archives, in CNSA's databases, and within the UAE's mission control systems, there are images, high-resolution visuals, spectroscopic readings, thermal data, everything captured by 7 spacecraft during those critical hours when the object was at its closest point to Mars, and none of it, not a single byte, has been shared with the scientific community or the public. The Skycam image from October 2nd remains the sole visual evidence we possess. A point of light in the Martian sky, captured one day before closest approach, one day before the resolution improved by orders of magnitude, one day before whatever it was that prompted 4 space agencies to collectively decide upon silence until they could ascertain its nature. The silence persists, and with each passing day, this silence itself becomes the most emphatic statement being made. Chapter 4. What it could actually be. The theories. While we await the space agencies to break their silence, let us explore the potential nature of the object, because the answer to that question will determine whether we are witnessing a standard astronomical event or something that will fundamentally alter humanity's understanding of its place in the cosmos. There are currently 4 primary theories under consideration, spanning the spectrum from the conventional to the extraordinary. Each theory is supported by some evidence, yet each also presents challenges. Understanding all 4 is crucial to comprehending why the silence from those who have analysed the October 3rd data might be so deliberately maintained. Theory 1. The ancient scout ship. This hypothesis has gained considerable traction within certain online communities. While it may sound like science fiction, the underlying mathematical principles are surprisingly robust. The theory posits that the object is not a naturally occurring celestial body. This is a probe, a constructed vessel originating from an advanced civilization within the Milky Way galaxy, launched sometime between 7 and 14 billion years ago. To provide context, our own Sun is merely 4.6 billion years old, and Earth is 4.5 billion years old. The advent of complex multicellular life on our planet occurred roughly 600 million years ago. Anatomically, modern humans have been around for perhaps 300,000 years. However, 3I Atlas predates all of this, potentially having been engineered and dispatched when the universe was less than half its current age. At that time, our solar system was non-existent, and the constituent elements that would eventually coalesce into Earth were still dispersed throughout interstellar space within nebulae. The rationale behind constructing such an entity is a subject of speculation. One prevailing hypothesis posits it as an observational instrument, a sophisticated recorder designed to traverse the galaxy. Its purpose would be to document cosmic phenomena and amass data over immense geological epochs. It is conceived not as a vessel manned by a crew, nor as one intended for return, but rather as an autonomous system, possibly powered by an unknown energy source. It might have remained dormant for eons, only activating upon encountering something of significant interest, such as a solar system with planets situated in a habitable zone, much like our own. Another variant of this theory suggests that 3I Atlas is an interstellar ark, carrying not living beings, but rather the accumulated knowledge, technology, and intellectual legacy of a civilization facing its demise. It was, in essence, a method for ensuring that some part of their existence would endure. It can be likened to a message in a bottle cast into the vast cosmic ocean eons ago, now arriving at our celestial doorstep. The timing of its arrival is particularly noteworthy. 3I Atlas is estimated to have entered the outer reaches of our solar system approximately 8,000 years ago. This period coincides with the dawn of human civilization's recorded history. It was around this time that the first urban centers were established in Mesopotamia, and the development of agriculture transitioned nomadic peoples into settled societies. It is conceivable that a civilization designing a probe to observe the evolution of an intelligent species might strategically time its arrival to coincide with this critical developmental phase, avoiding being too early to observe anything of note or too late to witness this crucial transition. This particular theory evokes unease in some, as it implies we have been under observation for millennia without our awareness. Theory 2 proposes an active reconnaissance mission. This concept shares similarities with the first theory, but suggests a more immediate and directed purpose. Instead of an ancient artifact drifting through space for billions of years, this hypothesis posits that 3I Atlas was intentionally dispatched to our solar system more recently, perhaps within the last few million years, by a civilization that detected our sun and sought a closer examination. The trajectory of the object lends credence to this idea. It is not merely passing through our system by chance. Its path aligns almost perfectly with the ecliptic plane, which is the flat disk containing the orbits of all the planets. Furthermore, its trajectory is designed to bring it into close proximity with multiple celestial bodies, including Mars in October and Jupiter in March. If one were designing a mission to survey diverse planetary environments and observe various types of worlds within a single solar system, this flight path would be exceptionally advantageous. The object's retrograde orbit, meaning it moves in the opposite direction to the planet's orbital motion, further supports this interpretation. This arrangement is actually beneficial for a reconnaissance mission. As the object traverses the solar system, the planets effectively come to it. If the intention were to deploy smaller observational probes, this retrograde motion would allow them to be released with minimal energy expenditure while still intercepting planetary orbits, as the planet's own orbital velocity would accomplish a significant portion of the work. Avi Loeb, a renowned astrophysicist who has been closely monitoring this object, has described it as a potential cosmic flyby reconnaissance mission. The intent is not necessarily hostile or friendly, but purely observational. It suggests a civilization conducting a comprehensive survey, gathering data on planetary systems throughout the galaxy, with our system being just one stop on its itinerary. Theory 3 presents the mainstream explanation: a natural comet with peculiar chemistry. This is the default interpretation favoured by most astronomers. According to this view, 3I Atlas is simply a comet. It originated in the outer reaches of the Milky Way, was ejected from its system through gravitational interactions with planets or passing stars, and has been adrift in interstellar space ever since. Its current passage through our solar system is purely coincidental. This perspective asserts that there is no intelligence or design involved. It is merely a celestial body composed of ice, rock, and frozen gases behaving as such bodies naturally do. Its unusual chemical composition is attributed to its formation environment, which differs from conditions found within our solar system. It is theorized that 3I Atlas originated from the Milky Way's thick disk, a region populated by older stars with distinct metallicity, elemental abundances, and different conditions during planetary formation. Comets formed in such environments might exhibit variations in their composition, potentially containing more carbon dioxide, less water, altered metal ratios, and different volatile compounds. While unusual, this is not deemed impossible, merely different. The trajectory is considered a statistical anomaly. While the probability of such a path occurring randomly is indeed low, low probability does not equate to impossibility. In a galaxy containing hundreds of billions of stars, each capable of ejecting comets into interstellar space, it is statistically probable that one such comet would eventually possess a trajectory that appears remarkably purposeful, purely by chance. This object may be that instance. The primary advantage of this theory lies in its avoidance of extraordinary assumptions. It does not require the existence of ancient civilizations, technological artifacts, or any form of intelligence. It simply posits nature operating according to its known processes, creating objects with a vast spectrum of characteristics, some of which may appear peculiar enough to spark human curiosity. Theory 4 introduces the hybrid stealth craft concept. This is the most imaginative of the proposed explanations, conceived by individuals contemplating how an advanced civilization might employ camouflage for its technology. The underlying principle is elegantly simple. Rather than constructing an overtly artificial spacecraft, an advanced civilization might identify a natural object, such as an asteroid or comet, and hollow it out. The natural rock and ice would serve as an external shell, providing concealment for the actual technology housed within. From an external perspective, the object would appear as a comet. It would exhibit a coma due to the deliberate venting of gases to maintain this illusion. Any observed outgassing patterns would be engineered to mimic natural phenomena, ensuring that any telescopic observation would yield expected results, that of a comet and nothing more. However, concealed internally would be a complex structure, sophisticated machinery, and a specific purpose. This theory effectively addresses several observations. It explains why 3i Atlas might display some cometary characteristics, while simultaneously exhibiting anomalies that deviate from the typical behavior of a comet. It suggests the object is a duality, a cometary exterior enveloping a technological core, representing the ideal disguise for interstellar travel. This approach would avoid attracting attention or triggering alarms, allowing the object to pass through solar systems undetected as harmless debris while carrying out its designated mission. This hypothesis has been seriously considered within astrobiology circles. It is plausible that if humanity were to develop interstellar probes, a similar strategy might be employed, utilizing an asteroid or comet as both a source of raw materials and a form of camouflage. This approach is both efficient and intelligent, and if humans can conceive of it, it is reasonable to assume that other civilizations might have considered it even earlier. Thus, we have these four primary theories: the ancient artifact, the active reconnaissance probe, the natural comet, and the camouflage technology. Each theory is supported by compelling arguments and has its proponents. Crucially, each leads to vastly different implications regarding our next course of action. Within secure facilities, where data from October 3rd is currently undergoing analysis, scientists are scrutinizing images, spectroscopic readings, and thermal data, endeavoring to determine which of these theories the evidence best supports. Alternatively, they might be encountering data that defies all existing frameworks, revealing something entirely unexpected that necessitates the development of a fifth or sixth theory, concepts not yet publicly discussed because they were beyond our prior imagination. We can engage in speculation, formulate hypotheses, construct models, run probability calculations, and participate in online debates. However, those with direct knowledge, those who have witnessed what 7 spacecraft observed on October 3rd, remain silent. Not yet, and certainly not to us. And that silence, more than any theory, underscores the profound importance of 3i Atlas. It signifies that whatever this object may be, its true nature warrants extreme caution in how the answer is ultimately revealed. Chapter 5 delves into the mathematical improbability, the sheer unlikelihood of its existence. Let us examine the figures involved. These are not the comforting numbers of everyday life, but rather the unsettling ones that prompt astronomers to pause and ponder questions they may not wish to have answered. The trajectory of 3i Atlas is not merely improbable, it is a path that should not exist. The distinction is significant. Its course does not defy physical laws or violate the principles of orbital mechanics. However, the statistical probability of such a trajectory occurring by random chance is so infinitesimally small that describing it as merely unlikely would be an understatement. Here's what we are confronting. On October 3rd, 2025, 3i Atlas passed within 29 million kilometers of Mars. Subsequently, on March 16, 2026, it is projected to pass within 54 million kilometers of Jupiter. These are two of the most scientifically significant planets in our solar system, apart from Earth, and the object will encounter both within a single flyby, at distances close enough for detailed observation. Let's dissect the extraordinary mathematical nature of this situation. Firstly, consider the alignment with the orbital plane. The ecliptic plane represents the flat disk within which Earth and the other planets orbit the Sun. It serves as the fundamental reference plane for our solar system. Imagine the solar system as a vinyl record. The ecliptic plane is its surface, and the planets trace paths along grooves spiraling towards the centre. The majority of comets and asteroids indigenous to our solar system maintain orbits that are largely within this plane, with minor deviations of a few degrees. This is a consequence of their formation from a common rotating disk of matter billions of years ago. 3i Atlas, however, is inclined at 4.89 degrees relative to the ecliptic. While this may seem like a small deviation, less than 5 degrees, suggesting near alignment, here's the crucial point. For an interstellar object, something originating from outside our solar system, with no ties to our formation history, there is no inherent reason for it to possess any particular alignment. It could have originated from any direction, above, below, or even perpendicular to the ecliptic plane. The vast majority of possible trajectories through three-dimensional space would not bring it anywhere near the ecliptic. The probability of this alignment occurring coincidentally is approximately 2 in 10,000, or 0.02%. Now the situation becomes even more disconcerting. These probabilities are independent factors. The alignment with the ecliptic plane and the precise timing of the planetary encounters are separate events. To calculate the combined probability of both occurring, we multiply their individual probabilities. 0.02% multiplied by 0.02% equals 0.0004%. This translates to 4 in a million, or roughly 1 in 250,000. However, the analysis is not yet complete. There is a third critical factor to consider. The trajectory does not merely pass near Mars and Jupiter, it does so in a manner that optimizes observational opportunities. The distances of closest approach are neither excessively near nor excessively far. An approach that is too close would result in the object swiftly passing by before instruments could adequately capture data. Conversely, an approach that is too distant would yield insufficient resolution. The distances maintained by 3i Atlas are, frankly, ideal for spacecraft-based observation. When the optimization of these approach distances is factored in, the combined probability decreases even further. Avi Loeb has calculated this composite probability at approximately 0.005%, which is equivalent to 5 in a million, or 1 in 200,000. Contemplate the significance of a 1 in 200,000 chance. If you were to shuffle a deck of cards and draw 5 specific cards in a precise order, that scenario would be more likely than this trajectory occurring by chance. If you purchased a lottery ticket, your odds of winning a significant prize would be greater than those of 3i Atlas randomly following this particular path. Now, let's address the 5-degree tilt, a detail that renders the mathematics even more intriguing. Why precisely 5 degrees? Why not a perfect alignment at 0 degrees, or perhaps 10, 20, or some other arbitrary value? There exists a hypothesis that offers an explanation, and its elegance is quite unsettling. It is known as the transit survey cone theory. Here's how it operates. Imagine an extraterrestrial civilization residing on a planet orbiting a star elsewhere in the galaxy. Their objective is to detect other planetary systems. How would they achieve this? In precisely the same manner as human astronomers, through transit surveys. They would monitor stars, patiently waiting for planets to transit across their faces, causing minuscule dips in stellar brightness. This method has proven to be our most successful avenue for discovering exoplanets, leading to the identification of thousands of worlds. However, there is a significant limitation. One can only detect planets that transit a star from their specific vantage point. If the observational alignment is incorrect, if the observer is not positioned at the right angle, the transit will not be visible. The planet could be present, yet its passage would remain undetected. Consequently, there exists a narrow conical region in space, a specific viewing angle, from which the planets of our solar system would be observable via transit survey. Any alien civilization situated within this cone would be capable of detecting Earth, Mars, and Jupiter. From their perspective, all 3 planets would appear to cross the face of our Sun. The width of this cone depends on the detection criteria. If the objective is solely to detect Earth-sized planets, the cone would be relatively narrow, perhaps 1 or 2 degrees. However, if the intention is to detect a broader range of objects, including the asteroid belt, a substantial ring of debris situated between Mars and Jupiter, the cone would expand significantly. The asteroid belt spans approximately 150 million kilometers in thickness. From a distant vantage point, objects transiting the Sun from anywhere within this belt would be detectable. Mathematical calculations indicate that this cone would be approximately 10 degrees wide. Any civilization located within this 10-degree band, either above or below the ecliptic plane, would possess the capability to detect our asteroid belt, our major planets, and Earth. Such a detection would indicate that our solar system warrants further investigation. Now, if such a civilization were to decide to dispatch a probe to explore our system, what trajectory would it employ? It would likely launch the probe along the same alignment that facilitated their detection. They would direct it straight down the center of the cone that enabled their initial observation. Such a trajectory would be inclined at precisely 5 degrees, positioned exactly midway between 0 and 10 degrees. 3i Atlas exhibits an inclination of 4.89 degrees, which, accounting for measurement precision, is effectively 5 degrees. While this could be a coincidence, it is a remarkably specific one. It is not merely a general alignment. It is an alignment that makes perfect sense if the object were deliberately targeted at our solar system by a civilization that detected us through a transit survey. The mass of 3i Atlas adds another layer to this complex puzzle. Based on its observed brightness and estimated size, the object possesses a mass of at least 33 billion tons, and potentially more. For comparative purposes, the International Space Station, humanity's largest constructed space habitat, has a mass of approximately 420 tons. The Space Shuttle, at its maximum loaded weight, was around 2,000 tons. SpaceX's Starship, currently the most massive rocket ever built, weighs 5,500 tons at launch. 3i Atlas is an astonishing 6 million times more massive than Starship. This implies that if the object is artificial, if it was manufactured rather than naturally occurring, the engineering prowess required is vastly beyond anything currently within human capabilities, to a degree that makes direct comparison almost meaningless. We are contemplating a civilization capable of manipulating billions of tons of material, accelerating it to interstellar velocities, and directing it along trajectories so precise that they can navigate between planets separated by hundreds of millions of kilometers. This is the level of technological sophistication implied if 3i Atlas is indeed a probe. It represents a capability not merely beyond us, but incomprehensibly beyond us, akin to the difference between a primitive stone axe and a state-of-the-art particle accelerator. Avi Loeb has meticulously compiled what he refers to as the 7 anomalies associated with 3i Atlas. The trajectory is designated as anomaly number 6, but it serves as the linchpin that connects all other anomalies. The trajectory dictates the object's destination, its encounters, and the timing of those encounters. If the trajectory is deliberate and targeted, then every other anomaly must be re-evaluated within that context. A natural comet exhibiting an unlikely trajectory might be considered a scientific curiosity. However, an artificial probe on a precisely calculated path represents something entirely different. It implies that someone specifically aimed this object towards us. It suggests that someone desired its presence here. It indicates that our solar system specifically is or was of interest to someone. The probability calculations, while stark, do not constitute definitive proof. A 1 in 200,000 chance is extremely unlikely, but not impossible. Unforeseen events do occur. People win lotteries. Lightning can strike the same location multiple times. Cosmic coincidences, however improbable, do happen. Yet, when an organization like NASA, the ESA, or the CNSA examines data from October 3rd and observes an object with a 1 in 200,000 trajectory exhibiting unexpected behavior, something that doesn't perfectly align with the characteristics of a comet, it compels them to ask difficult questions. These questions pertain to the wisdom of publishing the data immediately versus taking time to fully comprehend its implications. They involve inquiries into whether the trajectory itself is conveying a message, and whether whoever or whatever dispatched this object intended for us to notice it, to ponder its existence, and to pose precisely these types of questions. The mathematics are irrefutable. The trajectory is what it is. The probability is what it is. 1 in 200,000. These are the objective numbers. The meaning derived from these numbers and the conclusions we draw from them are the very questions that are keeping astronomers awake at night. And somewhere within the data collected on October 3rd, perhaps within images that have not yet been disclosed, there may lie an answer concerning an interstellar object that arrived with an orbital plane within 5 degrees of the ecliptic. This occurrence, with a probability of approximately 2 in 1,000, is already quite improbable, but our analysis has only just begun. Now let's consider the timing. 3i Atlas did not merely cross the ecliptic plane, it did so at precisely the optimal locations to encounter both Mars and Jupiter. Reflect on the requirements for such an event. Mars orbits the Sun at an average distance of approximately 230 million kilometers. Jupiter orbits at roughly 780 million kilometers. For 3i Atlas to pass in close proximity to both planets, it must intersect their orbital paths at the precise moments when those planets are actually present there. Not on the opposite side of the Sun, and not months ahead or behind their orbital positions. It must be there, right at the point of the object's passage. Chapter 6, October 29th, The Hidden Moment of Revelation. A specific date is marked on calendars in observatories across the globe, October 29th, 2025, a mere 22 days from now. This is the date when 3i Atlas will reach perihelion, its closest point of approach to the Sun. This distance is calculated at 1.36 astronomical units, approximately 203 million kilometers, situated just inside the orbit of Mars and just outside the orbit of Earth. Herein lies the critical significance of this date, its potential for revelation, and its frustrating inaccessibility. On October 29th, 3i Atlas will be completely obscured from the view of every telescope on Earth. The geometrical arrangement is straightforward yet insurmountable. As the object approaches perihelion from Earth's perspective, it will be moving towards the Sun. Subsequently, it will pass behind the Sun. Then, assuming all predictions hold true, it will re-emerge on the opposite side in late November. However, during this period of closest approach, when solar radiation is at its most intense, when the comet is expected to be most active, and when any unusual phenomena are most likely to occur, we will be unable to observe it. The Sun will physically obstruct our view, literally positioned between us and the object we are attempting to study. This situation presents more than just an inconvenience. It represents a critical lacuna in our observational timeline. Perihelion is the point at which comets typically reveal their true characteristics. When they are distant from the Sun, they are cold, inert, and dormant. The volatile substances, the frozen gases locked within their ice, remain frozen. Outgassing and activity are minimal. They appear essentially as dark masses of material drifting through space. But as they draw nearer the Sun, as the solar radiation intensifies, everything undergoes a transformation. The surface heats up, ice begins to sublimate, transitioning directly from a solid state to a gaseous one without ever becoming liquid. This process ejects streams of vapor and dust. The surrounding coma expands, a tail begins to form. In a very tangible sense, the comet awakens, energized by the Sun's power. At its closest approach to the Sun, known as perihelion, this activity reaches its peak intensity. The surface temperature can climb high enough to vaporize substances that were stable mere weeks prior. Complex organic molecules break apart. Subsurface ice, exposed by surface erosion, starts to vent. If a comet is destined to fracture, to split under the strain of thermal stress, perihelion is the critical juncture. For Comet 3I Atlas, perihelion means approximately 12 gigawatts of solar energy bombarding its surface. To put that into perspective, it's equivalent to the output of about 12 large nuclear power plants, continuously focused on an object only a few kilometers across for hours on end. The thermal burden is extraordinary. The stresses are immense. If 3 Atlas is a natural comet, we should anticipate specific occurrences, substantial outgassing, a dramatic increase in brightness as more surface area becomes active, a well-developed tail trailing behind as the solar wind propels the released material away from the sun, and potentially fragmentation if the nucleus has structural weaknesses. This is standard behavior for a comet at perihelion, behavior we've observed countless times with comets within our solar system. However, if 3I Atlas is something different, if there is any credence to the theory of an artificial origin, then perihelion might reveal remarkably different behavior. And this is precisely where the passive, wait-and-see approach becomes unsettling. There's a principle in orbital mechanics called the Oberth effect. When you're in close proximity to a massive object, when you're deep within a gravitational well, any alteration in velocity has magnified repercussions on your orbit. Spacecraft routinely exploit this. You wait until you reach your closest approach at perihelion, if you're near the Sun, and then you engage your engines. The change in velocity achieved at perihelion translates into significant changes in orbital energy. It is the most fuel-efficient method for substantially altering an orbit. Now, if 3I Atlas intended to alter its trajectory, if it wished to decelerate and become gravitationally bound to the Sun rather than continuing on its hyperbolic escape path, perihelion would be the opportune moment. One would wait until positioned behind the Sun, hidden from Earth's observation, and execute what is known as a reverse solar Oberth maneuver. By slowing down, instead of rocketing past the Sun and exiting the solar system, one would enter an elliptical orbit. It would remain. Aloeb has highlighted that the timing is optimal for precisely this maneuver. The object would be obscured from Earth. The thermal and radiation environment near perihelion would effectively mask any propulsion signatures. If one desired to conceal a change in trajectory, this is when and where it would be executed. Furthermore, if 3I Atlas is a mothership, if it carries smaller probes designed for deployment towards targets in the inner solar system like Earth or Venus, its retrograde orbit makes perihelion the ideal point for such deployments. The object is moving in the opposite direction of planetary orbital motion. A probe released at perihelion with minimal velocity could intercept Earth's orbit with relatively little energy expenditure. The planet would, in essence, collide with the probe as both celestial bodies orbit the Sun in opposing directions. This is the scenario of a Trojan horse. It appears innocuous. It seems like a comet passing through, behaving as comets do. But at the concealed moment, at perihelion when no one is watching, it performs something else. It deploys, it maneuvers, it reveals its purpose. Now, does anyone truly believe this is probable? Most astronomers would answer no. Most planetary scientists would argue that 3 Atlas will behave precisely as a comet is expected to, that it will brighten and outgas and possibly fragment, and that upon its reappearance in late November, we will observe exactly what we anticipate. A comet that has survived perihelion and is now heading back towards interstellar space. However, the inability to observe it during this crucial period troubles people. It troubles them sufficiently that multiple professional observatories have made arrangements to observe its re-emergence in late November with unusual intensity. It troubles them enough that space agencies are coordinating to have instruments ready the moment 3 Atlas becomes visible again. Because here lies the uncomfortable truth. If 3 Atlas passes behind the Sun as one entity and emerges as something else, we will have missed the transformation. We will have a before and an after, but no during. We will know that something changed, but we won't know how or why or precisely what transpired during those hidden hours. There's a philosophical parallel here, reminiscent of the thought experiment about a tree falling in a forest. If an interstellar object does something unusual at perihelion and no one can observe it, did it truly happen? But that's not entirely accurate, because we will know. We will know, based on what follows, if 3 Atlas re-emerges in late November on a different trajectory, or with altered properties, or accompanied by smaller objects that were not previously present, we will know that something occurred. We just won't know what we are supposed to label it. The data from October 3rd, the images we haven't seen, might provide context for this. If those images indicated that 3 Atlas was not behaving like a typical comet, then what transpires at perihelion becomes exponentially more significant. It becomes the moment when we either receive confirmation that this is merely an unusual natural object, or we receive something that compels us to re-evaluate everything. 22 days, 3 weeks, and a day. That's how long until this hidden moment arrives, until 3I Atlas disappears behind the sun and we lose our capacity to witness what happens next. Until we enter a period where we must wait and wonder and hope that upon its re-emergence, the object remains simply a comet heading back to interstellar space. Hope that it hasn't changed. Hope that it hasn't stayed. Hope that whatever those 7 spacecraft observed on October 3rd was intriguing but explainable, and that perihelion will be equally intriguing and equally explainable. But hope is not data. Hope is not observation. Hope is what one relies upon when the necessary information to draw conclusions is lacking. And presently, as the silence from space agencies persists, as the days count down to perihelion, hope is predominantly what we possess. That and the knowledge that in late November, when 3I Atlas reappears, we will finally ascertain if our hopes were justified. Chapter 7. The Nickel Without Iron Smoking Gun. Among all the anomalies associated with 3 Atlas, one stands out distinctly. It is an anomaly that astronomers find genuinely challenging to attribute to natural processes. One that, upon understanding the underlying physics, compels one to pause and reconsider everything previously believed about this object. It is the nickel, or more precisely, the nickel devoid of iron. Let us commence with some fundamental cosmic chemistry. When massive stars reach the end of their life cycles, when they deplete their nuclear fuel and collapse into supernovae, the ensuing explosion generates heavy elements through nuclear fusion. Carbon, oxygen, silicon, and indeed, metals like nickel and iron. These elements are forged within the extreme temperatures and pressures of the supernova core, subsequently expelled into space where they eventually contribute to the formation of new star systems, new planets, and new comets. Here lies the crucial point. Nickel and iron are generated concurrently. They form in the same stellar layers during identical nuclear processes. They possess similar atomic structures. They form chemical bonds in comparable ways. In nature, within every natural object we have ever studied, from meteorites to asteroids to comets, nickel and iron are always found together, invariably. The proportions may vary depending on the formation conditions, but both are consistently present. Discovering one without the other is akin to finding smoke without fire. It does not occur naturally, until 3 Atlas. In July and August of 2025, the Very Large Telescope in Chile conducted spectroscopic observations of 3I Atlas. Spectroscopy functions by analysing the light emanating from an object. Different elements absorb and emit light at specific wavelengths, creating a unique spectral fingerprint. By examining these spectral lines, one can identify the composition of an object. The VLT detected 22 distinct emission lines of nickel in the gaseous cloud surrounding 3I Atlas. 22. This is not a subtle indication. It is a strong, unmistakable detection. The comet was producing neutral nickel atoms in its coma, releasing them as gas vaporized from its surface. But here lies the conundrum. Ion emission lines were absent. Zero. Nothing. A complete lack. The instrument possessed sufficient sensitivity to detect iron if it were present. Other comets observed with the same equipment exhibit both nickel and iron. However, 3I Atlas displayed nickel and only nickel. To grasp the extraordinary nature of this, one must understand the temperature challenge. At the distances where 3I Atlas was observed, between 3.8 and 2.8 astronomical units from the Sun, the surface temperature is far too low to vaporize solid metal. Nickel has a melting point of 1,455 degrees Celsius. Its boiling point, the temperature at which it vaporizes into a gas, is 2,913 degrees Celsius. A comet's surface at 3 astronomical units does not approach these temperatures remotely. It might reach a few dozen degrees above freezing, perhaps 100 degrees Celsius in direct sunlight, not 2,900. So, how is 3I Atlas generating nickel gas? The conventional explanation for comets is that the nickel is not vaporizing directly. Instead, it is trapped within other compounds, specifically organometallic compounds, which can sublimate at lower temperatures and transport the metal atoms along with them. When these compounds decompose under sunlight, they release the metal. This is referred to as the nickel-carbonyl pathway, and it has been proposed as a mechanism by which comets can exhibit metal emissions despite low surface temperatures. This explanation accounts for the nickel, but it fails to explain the absence of iron, as iron forms similar organometallic compounds. If the process is releasing nickel, it should also be releasing iron. The chemistry is not selective. Both metals should appear in proportion similar to their abundance in the comet's composition. Unless, of course, 3I Atlas contains no iron, or unless the nickel-to-iron ratio is so extremely skewed, so dramatically divergent from anything natural, that effectively only nickel is detectable. Here's where it becomes even more peculiar. The nickel production was not constant. It was increasing dramatically. Between July and August, as 3I Atlas moved from 3.88 astronomical units to 2.85 astronomical units, the nickel emission rate increased 25-fold, 25 times more nickel in just 1 month. This is an exponential ramp-up far steeper than typical cometary outgassing patterns. By late August, 3I Atlas was releasing nickel at a rate described in the scientific literature as extreme. The production rate was higher than any comet ever observed at comparable distances from the Sun, and it was accelerating as the object approached perihelion. Now let us discuss the implications of this signature on Earth. When humans aim to purify nickel industrially, when they require nickel free from iron contamination, they employ a process known as the Mond process or the carbonyl process. This involves exposing nickel oxide to carbon monoxide at specific temperatures. The nickel reacts to form nickel carbonyl, a volatile compound that can be separated from the iron-rich ore. Subsequently, the nickel carbonyl is decomposed at higher temperatures to yield pure nickel metal. It is the standard industrial method for producing high-purity nickel. It is utilized in metallurgy, in manufacturing, and in any application demanding nickel alloys free from iron contamination. And it produces precisely what 3I Atlas is exhibiting: nickel emission without corresponding iron emission. This does not definitively prove that 3I Atlas is artificial. It does not prove it was constructed by intelligent beings. However, it does signify that the chemical signature we are observing from this object aligns more closely with an industrial process than with any natural process. The spectrum of 3I Atlas resembles a nickel refinery more than a comet. Could there be exotic natural chemistry at play that produces this? Possibly. Perhaps conditions during its formation in another star system might have resulted in metal ratios we have not yet encountered. Perhaps the nickel-carbonyl pathway is somehow selective in ways we do not yet comprehend. Perhaps there exists a physical process involving magnetic fields, or electrical discharges, or some other phenomenon that preferentially releases nickel over iron. But here lies the challenge for such an argument. We have observed a vast number of comets, hundreds from our solar system, and now 3 interstellar visitors. Not a single one of them has displayed this nickel without iron signature. If it is a natural process, if it is merely unusual chemistry from a peculiar formation environment, why are we only observing it now? Why is 3I Atlas the exception? The scientific paper analysing the VLT data employs precise language, as scientific papers should. It characterises the observations as extremely puzzling. It notes that the presence of nickel and iron in a cometary coma is already unexpected given the low temperatures. It acknowledges that 3I Atlas exhibits extreme properties concerning the production rates and abundance ratios of these metals. However, it refrains from stating what everyone reading the paper is thinking. This does not appear natural. This appears engineered. Avi Loeb has been more direct. He has publicly stated that the detection of nickel without iron is a signature known to exist in industrially produced alloys manufactured via the carbonyl chemical pathway. He has argued that while a natural explanation might be possible, the burden of proof now shifts to demonstrating what that natural explanation could be. Because at present, the most straightforward explanation that fits the observed data involves artificial nickel production. Which brings us back to the silence. If you are a space agency and you possess spectroscopic data from Mars orbiters during the October 3rd flyby, you have almost certainly analysed the chemical composition of 3 Atlas at a much closer range than the VLT observations. You have superior resolution, enhanced sensitivity, and more detailed spectra. What did those spectra reveal? More nickel, still no iron. Did the ratio become even more extreme at closer observation? Did you detect other elements, other compounds, other signatures that render the industrial interpretation more or less plausible? We do not know, because that data has not been released. The VLT observations from July and August are public, because they originated from a ground-based telescope operated by an international consortium that publishes its data according to standard scientific protocols. However, the data from the Mars spacecraft follows different channels that can be paused, channels that can be controlled. The nickel signature is the smoking gun. Not definitive proof, not absolute certainty, but the strongest single piece of evidence suggesting that 3 Atlas might be something other than a natural comet. And somewhere within the October 3rd data lie observations that either corroborate this signature or contradict it. Observations that might reveal even more extreme metal ratios, or that might demonstrate that at closer proximity, the iron finally appears, normalizing everything. In either scenario, those observations exist, and we are not being permitted to examine them. Chapter 8. The 7 Anomalies, Connecting All the Dots. We have been examining individual components of this enigma, the trajectory, the nickel signature, the coordinated silence. Now, it is time to consider the complete picture. Because 3 Atlas does not present a single anomaly, it presents 7. And when you juxtapose them, when you observe how they interconnect, the cumulative weight becomes difficult to disregard. Anomaly 2. The forward jet. When the Hubble Space Telescope captured images of 3I Atlas on July 21, 2025, something immediately captured the attention of astronomers. The object displayed a visible jet of scattered sunlight extending ahead of it, not behind it, which is where comet tails typically appear. It was pointing forward, towards the sun. The jet was 10 times longer than it was wide, a narrow, focused stream of material. And here is the peculiar aspect. For weeks following that Hubble observation, no proper tail developed. The typical cometary appearance, a bright head with a long tail streaming behind as solar wind propels gas and dust away from the sun, did not manifest until late August, nearly 2 months after its discovery. Normal comets develop tails as they approach the sun. The closer they get, the stronger the solar wind, and the more pronounced the tail becomes. But 3T Atlas initially presented this forward jet, a jet pointing in the incorrect direction, a jet that resembled exhaust from a nozzle more than natural outgassing driven by solar heating. By late August, a faint tail finally appeared. The comet began to look more like a comet. However, that initial forward jet, that 10:1 aspect ratio, that unusual directionality, it is not typical. It is not impossible, but it is not what one would expect to observe. Anomaly. 4. The carbon dioxide dominance. When NASA's James Webb Space Telescope and the Spherex Observatory analysed 3 Atlas in August, they detected something remarkable. The gaseous cloud surrounding the object, its coma, is composed of 95% carbon dioxide and only 5% water. This represents an 8:1 ratio of carbon dioxide to water. Compare this to comets from our solar system, which are typically water dominant. Most comets have a ratio closer to 1:1, or even favour water over carbon dioxide. An 8:1 ratio in the opposite direction is extraordinary. Now, carbon dioxide ice sublimes at lower temperatures than water ice. Dry ice, as we refer to it on Earth, transitions to gas at -78 degrees Celsius at standard pressure. Water ice requires 0 degrees Celsius. Therefore, a carbon dioxide-rich comet would begin exhibiting activity farther from the Sun than a water-rich comet, which actually aligns with what we observed with 3I Atlas. It was active at 4.4 astronomical units, much farther out than typical comets begin to wake up. The question remains, why? Why would 3I Atlas possess such an unusual composition? The answer likely lies in its formation environment. Different regions of the galaxy, distinct protostellar disks, varying ice lines around different types of stars. All these factors influence which materials condense and in what proportions they end up. 3 Atlas likely formed in an environment vastly different from the region where our solar system originated. Perhaps around an older, cooler star, perhaps in a region with different elemental abundances. However, here is where it connects to the other anomalies. Carbon dioxide is not merely a different volatile substance, it is a propellant. If one intended to maneuver a spacecraft using cold gas thrusters, carbon dioxide would be an excellent choice. It is stable, it is easy to store, it sublimes at accessible temperatures, and a spacecraft carrying substantial reserves of carbon dioxide ice could maintain a cometary appearance while possessing ample material for trajectory adjustments. Is this what we are observing? Propellant reserves masquerading as natural volatiles, or simply unusual cometary chemistry? The composition alone does not provide a definitive answer, but when considered alongside the trajectory and the nickel signature, it represents another data point that supports both natural and artificial interpretations. Anomaly. 5. The extreme negative polarization. This anomaly requires an understanding of how light behaves. When sunlight reflects off a surface, it can become polarized, meaning the light waves align in a specific direction. The degree and type of polarization provide information about the reflecting surface, its texture, its composition, its structure. 3 Atlas exhibits extreme negative polarization. The polarization measurements fall outside the normal range for comets, significantly outside. This suggests that the surface properties, or the properties of the dust grains within the coma, are unusual. Its form, its makeup, its internal arrangement are all distinct. Negative polarization can manifest with specific particle varieties, extremely minute particles, atypical mineral compositions, distinctive configurations and particular orientations. However, exceptionally strong negative polarization, that is uncommon. That necessitates elucidation. Some investigators have posited that this might signify the presence of rare minerals formed within the environment where 3I Atlas originated. Others point out that synthetically fabricated particles, especially certain classes of manufactured materials, are capable of generating pronounced negative polarization. Neither viewpoint offers a definitive conclusion, yet it remains another characteristic that deviates from the conventional comet profile. Anomaly. 7. The alignment of the WOW signal. On the 15th day of August 1977, the Big Ear Radio Telescope situated at Ohio State University registered a robust narrow-band radio transmission at 1,402.4 MHz, the precise frequency of the hydrogen line. The signal persisted for 72 seconds. Its nature was so peculiar, so fraught with potential significance, that astronomer Jerry Ayan felt compelled to scrawl "wow" in the margin of the computer printout. The signal has never been redetected, never replicated, nor ever explained. This transmission originated from the sector of the sky designated Sagittarius, with a right ascension of 19 hours and 25 minutes, and a declination of -27 degrees. This points generally towards the core of our galaxy, where countless billions of stars are densely packed within the galactic bulge. Now consider this disquieting coincidence. When one traces the trajectory of 3I Atlas in reverse, when one ascertains its location in 1977, it was situated at an approximate distance of 600 astronomical units from Earth. Furthermore, its celestial position at that juncture was separated by a mere 9 degrees in right ascension and 8 degrees in declination from the origin point of the WOW signal. 9 degrees out of 360 degrees encompassing the entire celestial sphere. The probability of such an alignment occurring by chance is approximately 0.6%, 6 instances in 1,000. Could 3I Atlas have been the source of the WOW signal? If it were at a distance of 600 astronomical units, the energy output required would have been in the range of 0.5 gigawatt to 2 gigawatts. This is comparable to the output of a standard nuclear reactor on Earth, a substantial power requirement, yet not beyond the realm of possibility. Additionally, the signal exhibited a blue shift, indicating that the source was moving towards Earth, which aligns with the predicted trajectory of 3I Atlas. The WOW signal could conceivably have been a radar pulse, a scanning beam traversing space, actively pinging neighbouring star systems to identify exoplanets. And it just so happened that we were within the beam's sweep for 72 seconds as it passed by. If 3I Atlas detected planets within our habitable zone during that sweep, it might have subtly altered its course, accelerating its approach to reach us sooner. By the time of its predicted arrival in 2025, it will have been in transit for 48 years since that 1977 detection. All of this alignment could be a pure stroke of fortune. 6 chances in 1,000. Unlikely, but not entirely inconceivable. Another piece of evidence that admits of dual interpretations. Let us examine what all 7 of these anomalies reveal when considered collectively. Individually, each can be accounted for through natural phenomena. The size might be a statistical anomaly. The forward-directed jet could be an atypical outgassing pattern. The nickel signature might indicate exotic chemical processes. The prevalence of carbon dioxide could be a consequence of its formation environment. The polarization might stem from unusual dust properties. The trajectory might be a matter of random chance. The alignment with the WOW signal might be coincidental. However, when all 7 are present simultaneously, it is then that naturalistic explanations begin to demand increasingly numerous qualifications. An ever greater accumulation of improbable circumstances that all happen to converge on a single object. It is not impossible, but it is highly improbable, and the more such factors are added, the more improbable the scenario becomes. Avi Loeb has assigned 3I Atlas a rating on his own scale. This scale ranges from 0, definitively natural, to 10, unequivocally artificial and potentially threatening. He currently places it between 2 and 4. It is not 0, meaning it is not considered naturally occurring by default, but it is not sufficiently high to warrant any definitive pronouncements. It resides squarely in the ambiguous middle ground, where further data is imperative for a conclusive determination, and that is precisely where we find ourselves. That has been our position since the 3rd of October, stuck in this ambiguous middle, awaiting information that exists but has not yet been disclosed, waiting for space agencies to break their reticence, waiting to ascertain whether these 7 anomalies upon close examination by 7 spacecraft, will be readily explained away by terrestrial processes, or if they will be corroborated by supplementary observations that render the hypothesis of artificial origin increasingly difficult to disregard. The data is available. The observations have been made. The analyses have been performed. Somewhere, individuals are aware of whether these anomalies resolve or intensify under meticulous scrutiny. They know what the images captured on the 3rd of October depict. They understand what the spectral readings reveal. They comprehend what the thermal signatures indicate. They possess this knowledge, and they are withholding it from us not yet,